Square roots. Our objective is to estimate square roots, simplify, add, subtract, multiply, and divide square roots. Who uses this? Mosaic artists can use square roots to calculate dimensions based on certain areas. Let's start with some vocabulary to know. The radical symbol is basically your square root symbol. The radicand is the number or expression under the radical symbol. So it's no longer just going to be the number 49. You might have an expression under there. The principal root is the radical symbol. The radical symbol indicates only the positive square root of a number. Rationalizing the denominator. Multiply both the numerator and the denominator by a number that produces a perfect square under the radical sign in the denominator. And like radical terms, square roots that have the same radicand. Let's start with some estimation. For example, we all know that the square root of 25 is 5. We have the negative out here. We've got negative square roots of 25 is negative 5. And plus or minus, we have the square root of 25 equals plus or minus 5. Or you can say, hey, 5 or negative 5. So let's estimate the square root of 34 to the nearest tenth. Well, what's a perfect square that's smaller than the square root of 34? The square root of 25. Alright, what's one that's bigger? The square root of 36. So we know we're going to fall between the square root of 25 and the square root of 36. So you know your number is going to fall between either 5 or 6. Your next step is to look at which direction it's closer to. Is the square root of 34 closer to 36, or is it closer to 25? Well, because 34 is closer to 36 than 25, that means it's closer to 6 than 5. So let's try a couple numbers. So let's try 5.8. So 5.8 squared is 33.64. Too low. So we're going to try 5.9. 5.9 squared is 34.81. That one's too high. So that means we've now narrowed it down to the fact that we know it's got to be closer to 6. So we're trying numbers bigger than 5.5. And we know that it's bigger than 5.8, but smaller than 5.9. Well, is it closer to 5.8 or 5.9? Well, if it's closer to 33.64 than it is to 34.81, we know it's got to be closer to 5.8. So the square root of 34 is about 5.8. You can check your calculator if you'd like. But this is a way to know how if you're close or you're really far off with your estimation. Or when you take the square root of something, you might not know what the square root of 34 is off the top of your head, but you know your perfect squares like 25 and 36. So you know your number's got to be between 5 and 6. You know it's got to be closer to 6. And then when you did a little bit of math here, you know it's going to be closer to 5.8. So let's look at some properties of square roots. So the product property of square roots. The square root of a product is equal to the product of the square roots of its factors. That might sound a little confusing, so why don't we look at the numbers. The square root of 12. Well, that's the same thing as saying the square root of 4 times the square root of 3. So the square root of 4 times 3. Well, when we do that, we know what the square root of 4 is. That's 2. So that essentially equals 2 square roots of 3. In the end, if you're looking at it algebraically, if you have two numbers being multiplied together under the same square root, you can separate them out. Or if they started separate, you can multiply them together and put them under the same square root, or same radical symbol. All right, let's look at the quotient property of square roots. The square root of a quotient is equal to the quotient of the square roots of the dividend and the divisor. So if we take the square root of 25 divided by 16, we can just separate it. What's the square root of 25? And then what's the square root of 16? Well, we know what the square root of 25 is, it's 5. And we know what the square root of 16 is, that's 4. So very similar to multiplication, when you have a radical symbol with a fraction under it, you can separate it so that the radical symbol is on the top and the bottom. Or if it started where it was in the numerator and denominator, you can simply push them together and put them underneath the same one. So they go back and forth for both multiplication and division. Let's practice. So we're going to simplify each expression. So let's look at negative square root of 50. Well, we know that 50, so if we're going to leave our negative over there, is like saying 25 times 2. So that's the same thing as saying the square root of 25 times the square root of 2. Well, we know what the square root of 25 is. That's 5. So we've got negative 5 square roots of 2. And we've just simplified the expression. And once again, we've talked about it in the past, but when you're simplifying, you want to make sure you simplify completely. Don't just go one step and call it good. Let's look at a division example. We have the square root of 49 divided by 81. So we can separate this out. So we have the square root of 49 over the square root of 81. Well, we know what the square root of 49 is, that's 7. And we know what the square root of 81 is, that's 9. So it's now simplified. Take a moment and pause the video and try C and D. Now that you've had a chance to try C and D, let's try it together. We have the square root of 2 times the square root of 18. Well, why don't we try doing this one backwards? So instead of separating it out, we're going to push them together. So we have the square root of 2 times 18, which is the same thing as the square root of 36, because 2 times 18 is the square root of 36. Okay, well, we know what the square root of 36 is, that's 6. Much easier than trying to take the square root of 2 and the square root of 18. Let's look at D. We have the square root of 96 over the square root of 6. So let's push them all together. So we have 96 divided by 6, all underneath the same radical symbol. And, well, 96 divided by 6 is 16. So we have the square root of 16. And we know what the square root of 16 is, that's 4. Let's take it up a step. Now we're going to rationalize the denominator. So we're going to simplify by rationalizing each denominator. When you rationalize the denominator, you're going to multiply the top and the bottom, so the numerator and denominator, by something that's going to get rid of the square root. So if we multiply the bottom, or the denominator, by 3, and the numerator by, the square root of 3 and the square root of 3, when you push these together, we're going to leave the top by itself for a second. It lets me write the 2. If we look at our denominator, we have the square root of 3 times the square root of 3. Well, that's the same thing as saying the square root of 9. So we have 2 square roots of 2 times the square root of 3 over the square root of 9. Well, we know what the square root of 9 is. That's 3. That looked like an equal sign. There we go. And then we have 2 times the square root of 2, or 2 square roots of 2 times 3. So we can just multiply our 2 times 3. So in the end, we have 2 square roots of 6, and we simplified our denominator, and we now have a 3 as our denominator, which is not a radical, so therefore it's simplified. You don't ever want to have a square root in the denominator, then it's not simplified. Alright, take a moment and pause the video and try B. Alright, now that you've had a moment to try B, let's try it together. So we're going to multiply, in this case, both the numerator and the denominator by the square root of 2. You could have done the square root of 18 on the top and bottom, but you would have ended up having to do a little bit more math. But it wouldn't be the wrong answer in the end. Alright, so in the numerator we have the square root of 8 times 2. So in the numerator we've got the square root of 16. And in our denominator we have the square root of 36, because 18 times 2 is 36. So that's why we were able to pick 2, because we were able to make it a perfect square with a smaller number than 18. Alright, so we have 4 over 6. If you want, we can keep going. So we have 4 over 6, which ends up being 2/3. Alright, let's look at like radicals and unlike radicals. So like radicals, the same number is going to be underneath. Okay, so your radicand, we use our mathematical terminology here, your radicand is going to be the same. So we have 15 and 15, ab squared and ab squared. Those are like radicals. Your unlike radicals have a different radicand. So like 5 and 2, x and 3x, xy squared and x squared y. They're different, so they're unlike radicals. So when adding and subtracting square roots, simplify each radical. Step 1. So we got to simplify each radical first. Step 2. Combine like radical terms by adding or subtracting their coefficients. So just like when you were combining like terms back in Algebra 1, when you're combining like radical terms, you need to make sure that you have like radicals before you can do so. Let's practice. Alright, so we have 5 square roots of 2 plus 3 square roots of 2. Are our radicands the same? Yes. So since they're the same, we can simply add our 5 and 3 together, which gives us 8 square roots of 2. And we're done with that one. Let's look at B. B is a little bit trickier. One of them you need to simplify down, and that would be the square root of 12. So let's look at the square root of 12. You can rewrite the square root of 12 as the square root of 4 times the square root of 3. The square root of 4 is 2, and we don't have anything for the square root of 3 that's nice. So now your problem looks like this. 5 square roots of 3 minus 2 square roots of 3. Since you now have like radicals, you can subtract. 5 minus 2 is 3, so we have 3 square roots of 3. And your quick recap. Perfect square is the product of a number multiplied by itself. If you have a negative fraction, when you simplify, it's still going to be negative. When splitting up a square root, use a perfect square. Makes your life so much easier. Rationalizing the denominator. Get rid of the square root in the bottom of the fraction. Like radicals. And unlike radicals. And then to add and subtract, simplify, then combine. And that sums up our lesson on square roots.